Well, hey everybody, Mr. Reeves with you as we are reviewing for the big quiz on proportional and non-proportional linear relationships. So in this first video, we're going to be looking at Module 4 and reviewing some key ideas about proportional relationships. Over here, speaking of key, they've got some key vocabulary terms as a reminder of things we learned about. All right, constant of proportionality, proportional relationships, rate of change, unit rate. All right, and then we're going to be talking about constant rate of change and slope and such fun things as well. All right, so let's go ahead and look at the example here and use this example to review some of these key concepts. It says a store sells onions by the pound. Is the relationship between... What does that say? I have no idea what that says. Is the relationship between the cost of the number of pounds of onions and the cost of onions proportional? All right. If so, write an equation for the relationship and represent the relationship on a graph. All right. So let's talk about a proportional relationship. If there is a proportional relationship, let me write this down. Sorry, it takes a while to write it down. If there is a proportional relationship between two variables, all right, and usually the variables we refer to are x and y, and on a table, that first one is usually x and the second one is usually y, then y, the second variable, can be found by taking the first variable and multiplying it by a constant. And we call that constant k the constant of proportionality. All right? The constant of proportionality. So y is equal to kx. And if you take that relationship and you rearrange it and solve it for k, you get k is equal to y divided by x. All right, so the constant of proportionality in a proportionality relationship is y divided by x. Okay, if all of the y's divided by all of the x's are the same, then we say it's a proportional relationship. So if you take a look, they did that right here, right? If you take a look, they did y divided by x for the first one, and they got 1.5 or $1.50 per pound. They did the same thing for that one, and they did the same thing for that one, right? Every time they did y divided by x, so y divided by x turned out to be 1.5, which is equivalent in money to $1.50 per pound, okay? Now, just so you know, that would also be the unit rate. That would be the unit rate, because you'll notice that bottom unit is 1. All right, and when the second unit or the bottom unit is 1, that quantity, sorry, not the quantity is 1, all right? When that second quantity is 1, that tells you that your rate is a unit rate. So you notice that one's 3, that's 750, that's 9, so it's not a unit rate. But on this table, if I were to put a 1 here, 1.5 would go down here, and that is my unit rate. Okay? And by the way, our rate of change would be our change in y over our change in x. And if you notice from here, from 3 to 750, it went up 450, and that one went up 3. And if I did 450 over 3, guess what I get? I get 1.50. So that is my rate of change. Wow, so my rate of change is equal to my unit rate, which is equal to my constant of proportionality. So k is equal to the unit rate, which is equal to my rate of change. That's a magical number, that constant of proportionality, when you have a proportional relationship. And when you go and make a graph, when you graph a proportional relationship, what do you get? You get a linear relationship, which means it's a line. We usually say a straight line, but all lines are straight. All right, that goes through the origin. All right, so you get a relationship that is linear that passes through the coordinate 0, 0, and that coordinate 0, 0 we call the origin right there. Okay, there is our origin, and there's our linear relationship. And then our change in y, look, if we go from that point to that point, it goes up 1.5 and it goes to the right 1. Hey, that's our slope, our constant rate of change. So k in this case is equal to m, which is equal to 1.5 over 1, right? Or we could look at that as 3 over 2, right? 1, 2, 3 over 2. Do you see that? Up 3 and over 2. Because what does 3 over 2 simplify to? Or as a decimal, it's 1.5, right? Okay, there we go. And the equation, here we go. One last thing, the equation is going to be y is equal to k times x. But what did k equal? K equaled 1.5, so our equation is 1.5x. All right, and these points were the points in the table, and you could see they all line up. All right, so there's a quick review. Now let's do a few of these problems here. Okay, Steve uses 8/9 of a gallon of paint to paint 4 identical birdhouses. How many gallons does he use for each birdhouse? In other words, they want the unit rate. Okay, so if you have a rate and you want to change it to a unit rate, all right, you want that bottom number, that second unit, to be 1. Well, you can do that by dividing. So if I have 8/9 for 4 birdhouses, so 8/9 gallons of paint for 4 birdhouses. And I want instead 1 birdhouse on the bottom. Well, what would I have to do to take that and make that happen? I would have to divide that bottom number by 4. But if I divide the bottom number by 4, I have to divide the top number by 4. So what do I want? I want 8/9 divided by 4. That's going to give me my unit rate, or the first number divided by the second number. It will always work that way. All right, the top quantity divided by the bottom quantity. When you do that, that makes that bottom quantity 1, and you will get the unit rate. All right, so let me use a different color because I'm over here in the blue. So I'm going to do 8/9 divided by 4 is the same as 8/9 times 1 over 4. And we know when we are multiplying, we can simplify before we multiply. 4 goes into 4 once. 4 goes into 8 2 times. And what do I end up with? I end up with 2/9. So what does that mean? 2/9 of a birdhouse. Not 2/9 of a birdhouse. 2/9 of a gallon per birdhouse. Okay? 2/9 of a gallon per birdhouse. It takes 8/9 of a gallon for 4. You take that 8/9 and you divide it by 4, and that gives you 1. And that should make sense, right? Because 2/9 plus 2/9 plus 2/9 plus 2/9. Each birdhouse is 2/9. What do I get? I get 8/9 total, right? 1 birdhouse, 2 birdhouses, 3 birdhouses, 4 birdhouses. Does that make sense? I hope that makes sense to you. All right, what about this? Ron walks a half a mile in 10 minutes. Stevie walks 0.25 miles in 6 minutes. Find the unit rate in miles per hour. Now, one of the things you have to be careful about with rates and unit rates is the actual rates they're giving you. Notice they gave us miles per minute, but they want it ultimately in miles per hour. All right, yellow doesn't show up so much. They want miles per hour, right? So let's start with Ron. And Ron has 0.5 miles in 10 minutes. So the first thing I'm going to do is I'm going to find his unit rate. So what did we just do? We're going to do 0.5 divided by 10. All right, 0.5 divided by 10. And I don't mind if you go ahead and use a calculator for these problems, although we really should be able to do this one without a calculator. But 0.5 divided by 10, when I do that, what do I get? I get 0.05. 0.05 what? Miles per minute, okay? That is Ron's unit rate in miles per minute. Now, we don't want miles per minute. We want miles per hour. So how many minutes in an hour? Well, there are 60 minutes in 1 hour, right? There are 60 minutes in 1 hour. So if I multiply that number by 60, that's going to give me an hour. But if I multiply the top number by 60, I have to multiply that bottom number by 60, right? So now I'm going to take that answer that I have in miles per minute, and I'm going to multiply it by 60. And when I do that, I get 3. All right? So what do I know? I know that Ron goes 3 miles per hour. All right, so just to review, I took the rate they gave me in miles per 10 minutes. I divided by 10 to give me miles in 1 minute, and then I multiply that by 60 over 60. I multiplied both the distance and the time by 60, and that gave me miles per hour. Okay, so now I'm going to do the same thing with Stevie. All right, so I'm going to go ahead and erase all of this. And simply write down that Ron was 3 miles per hour. Okay, so now we're going to take a look at Stevie. So Stevie walks 0.25 miles in 6 minutes. Okay, so what did I do first? I divided, right? I divided 0.25 divided by 6. So I'm going to go to my handy-dandy calculator again. All right, and I'm going to go 0.25. See how here I did 0.5 divided by 10? Now I'm doing 0.25 divided by 6. And when I do that, I get that number right there. So approximately 0.42. Approximately 0.42 miles per minute. 0.042. I knew that wasn't right. 0.042 approximately miles per minute. Now, just a hint, keep that number in your calculator because that's the actual number that's the actual value. This is an approximate value. All right, so I have it approximately what it is there, but keep the actual value in your calculator. And then remember what we have to do, but we want it per hour, so we're going to multiply each of those by 60. All right, and by keeping that actual value in my calculator, keep it there, then I'm going to take that answer and I'm going to multiply it by 60. See how I did the same thing? I multiplied by 60 up here, right? So now I'm going to multiply by 60 here. I multiplied by 60 for Ron. Now I'm multiplying by 60 for Stevie. And this one gives me 2.5. All right, so that number cleaned up nicely. 2.5 what? Miles per hour. So as you can see, who's the faster walker? The faster walker is Ron because he goes 3 miles per hour, whereas Stevie, it's way over here, he only goes 2.5 miles per hour. All right, so let's go on to the next couple problems here. All right, it says the table shows how far animals can travel at their maximum speeds in a given time. Write each animal's speed as a unit rate. So again, if we want a unit rate, we're going to divide that first quantity by the second quantity, and that's going to make that second quantity 1, which will give us a unit rate. All right, so let's do this pretty quickly on the calculator here. I'm going to go ahead and clear everything out. I'm going to do 33 divided by 1/2. Of course, 1/2 is the same as 0.5. 33 divided by 0.5 is 66. That shouldn't surprise us because dividing by half is the same as multiplying by 2. So 66 feet per second. All right. Now I'm going to go back to my calculator and I'm going to do for the giraffe now 115 divided by 2.5. And for that one, I'm going to get 46 feet per second. Okay. And then finally for the last one, I'm going to do 117. This is for the zebra. 117 divided by 2. And that one's going to give me 58.5 feet per second. Okay? All right. So, write each animal's speed as a unit rate in feet per second. We did that. Which animal has the fastest speed? Well, it sure looks like that would be the elk. And the elk speed is 66 feet per second. All right. Okay. Next question. How many miles could the fastest animal travel in 2 hours if it maintained the speed? All right. So here again, we have a problem because once again, they're talking hours and we have the distance per second. So we have a couple options. We can change the rate to hours here to see how far it goes in hours, or we can change the hours to seconds. All right, but it wants to know how many miles in 2 hours. So let's convert. What we really need to do is we want 66 feet per second. And when we're done, what do we want? We want blank miles per hour. All right, so what are we going to do here? We've got feet per second. And when we're done, we need miles per hour. All right, so if we think about it, okay, I need to get from seconds to hours. What do I have to multiply by to get from seconds to hours? Well, there are 60 seconds in 1 hour, right? And there are there are not 60 seconds in 1 hour, Mr. Reeves. There are 60 seconds in 1 minute, all right? And there are 60 minutes in 1 hour. So what am I going to have to do? To get from seconds to hours, I'm going to have to multiply by 60 times 60. Well, what is 60 times 60? That is 36 with 2 zeros, 3,600. All right, so I'm going to do it in blue like I did up top there. So the first thing I'm going to do is I'm going to multiply the top and the bottom by 3,600. Okay? Why did I do that? Because that's going to change from seconds to hours. All right, but now I want to know, I got to get that. That's going to give me in feet per hour, but then I want it in miles. You know what? Let's just do this first. All right, I don't want to make this too confusing. So let's do that. Let's just take our 66 feet, and let me write it like this. We have 66 feet in 1 second. And then I'm going to multiply that by 3,600 on the top and 3,600 on the bottom. And that's going to give me the distance that I would go in 1 hour. Okay, so I'm going to take 66. Here we go, 66 times. And what am I multiplying it by? 3,600, because I'm going from seconds all the way to hours. Okay, so that's how fast he goes. He goes 66 feet in 1 second. Then I multiply that by 3,600 and I get 237 237,600. Wow, 237,600 feet in 1 hour. All right. Wow, if he goes 66 feet in 1 second, he's going to go 237,600 feet in 1 hour. That's a lot of feet in an hour. But they don't want feet, they want miles, right? Oh my goodness, this problem is crazy. Well, how many miles per hour? Well, there are 5,280 feet in a mile. So even though he's going 237,600 feet, that's feet, not in miles. So now what do I have to do? Now I have to divide that by 5,280. All right, and that will tell me how many miles it is. So I'm going to go to my calculator and I'm going to go 237,600 divided by 5,280, and I get 45. Woo! 45 miles per hour. Alrighty? Okay. So now we're talking. So if it goes 45 miles per hour in 2 hours times 2 hours, we will get 90 miles in 2 hours. Okay? 90 miles in 2 hours. All right, that was a little bit more complicated than we need it to be. If you can take a rate and you can find the unit rate, I'm not going to spend a lot of time asking you to convert between different types of rate. All right, rate analysis is something that you will do when you get to integrated math 1. All right, so I'm going to skip that one. I'm going to go down to this bottom one, and then we're going to be done. All right, the table below shows the proportional relationship between Juan's pay and the hours that he works. All right, so it is a proportional relationship. So what do we know? If this is x and this is y, we know that y divided by x is going to equal k, the constant of proportionality. Okay, so let's find it. They gave us this pair right here. So if we do 40 divided by 2, we find out that k is 20. All right, so that means that y is equal to 20 times x. These values are 20 times that value, right? So, or if we go the other way, x would be y divided by 20. If the y is 20 times bigger, the x is 20 times smaller. So what's 80 divided by 20? 80 divided by 20 is 4, right? 4 times 20 is 80. Well, what's 5 times 20? That's 100. And 6 times 20 is 120. So you can see if we take any of these y's divided by x, we're going to get 20 every time. Y divided by x equals 20, and that is our constant of proportionality. That's our constant of proportionality. Now, if we plot these points, what should happen? We should get a straight line. All right, we should get a linear relationship. All lines are straight. That goes through the origin. So let's do this real quick. There's 240 right there. Okay, there's 480. There is 100 right there. And there is 120 right there. All right, and you notice it says to connect the points with a line. So why don't we do that? And when we connect those points, notice it is a linear relationship that goes through the origin. All right, and the equation of that line would be y equals 20x. All right, so I apologize. Looking back, maybe I would not have spent so much time on the converting between those rates. So if you can find the constant of proportionality, if you understand the requirements of a proportional relationship, if you understand what a rate of change is, and you can find a unit rate given a rate, you're in good shape. If you can then take those unit rates and convert them from miles to hour and feet per second and all that stuff, that's an added bonus, but I'm not going to be focusing on that as much as the bigger ideas here. All right, until next time, I'll see you. Bye.